Okay, it's been a while since I've made a video, and I've managed to get a quiet afternoon to myself, so it's probably time to do a bit more on the relay computer. So in my last video I was making this, which is the Y backplane. So the next job was to actually fit it to the computer, which is what I'll do now. And effectively that's going to go into there, so then it can basically connect with the cards at the front. If I reach over here, an example of this Y card is the memory card here. So this is actually a double card, so it actually connects together through these interconnects, and therefore it's got two rows of connectors at the back. And the idea basically is then that they'll fit into those connectors just there, like that. So okay, let's get started. So first job basically be to line all this up. So if I connect these in, put those into the bay, connect up at the back, and then get everything lined up, and then basically I can screw in the connectors as you see here. So right, let's do that. Right, well that was extremely fiddly. And actually this one's got a bit more working room than the others. So these ones actually you can see with all the ribbon cables going through the back of the backplane. It was really tricky. Like I said though, I don't remember having that much trouble with the other ones. But, oh, there we go. Right, okay, so next thing now will be to put the power cables back in again. So this is the Z one for the Z backplane over there. So I'll just feed that through and plug that in that way. The Y backplane one is for this backplane, so that'll just go in at the top like that way around. So that's going to be another little fiddly job, so I'll do that in a second off on the camera. And then we need to start wiring up the backplane. So that's where all these mix of cables are. So these are all a real rat's nest at the moment, and that's because these are all made out of bits of old cable that I have had in the past. So what I really need to do is make up some new cables, and I don't know if I've actually got any ribbon cable at the moment. I don't think I have. So what I might do is make these together temporarily, and basically what tends to happen is I've got no idea which way around these will go. So what I tend to do is just experiment till I get it the right way around, and you can see if the signals are coming out wrong on the bus, if it's the wrong way around. So hardly scientific, but there we go. So like for this one as well, so this one's ending in a right mix of a cable, this one. This one's a sort of a wire out cable I use, so that's all good. Right, okay, right, well let's get these power cables in first and then we'll move on to the next job. Okay, so I'm going to try a power on now and just see if the power is going through to those cards. Now, I've not got any other connections into the address bus, but at least if it comes on and I can sort of flick it on and off, I know the power's there okay. So I'm just plugging in the mains at the back. This is the first time I've turned this computer on in quite some time as well. So one does wonder what will happen. Okay, it's looking promising. The right lights are on. Good, so that's off, that's on. Well, the light's looking about right. Yeah, that's looking good. So if I try a... yeah, that's making the right sort of sounds and noises, so that's good. So what I need to do now is start connecting the cables up at the back to those cards so that data can get through here. So what I just did then was try to, if I just flick all the switches just off camera, do a deposit. What I expect to see there is the all bits go through and appear on the address bus. Now, of course, that's not happening at the moment because there's no data bus connected and there's no address bus connected. So that'll be the next tasks, and we'll see where that works okay. Right, I didn't bother videoing the actual work of fitting all these cables around because it was just taking so long. And it's really, really fiddly. I've probably taken these brackets off 2 or 3 times now to get the connectors in on this side. So I'll just give you a quick summary of where we've got to. So the first job was just routing the address bus, which basically comes in off here, goes around here, takes a right angle, dips behind, back out again, and then folds back on itself to go along here and then into the address bus connector there. And luckily, because that's both ends of the cards, it's just effectively just a straight ribbon to ribbon cable. There's no twists or anything fancy like that. So that's the address bus one, so that's all okay. Power, you probably saw me do a little bit earlier, goes in here and here, comes out here and then follows these cables up there. That was there, so that's all good. What next have we got here? Data and control bus. So that one is coming actually off the back of this card, goes along here, and then into the back of this card here. So that's quite nice. That's just again another straight one that can go into here from there. So that's quite nice. Actually, that one then comes off the other side of this card, because as you know, these effectively act as a bus all the way along the card. So effectively this comes onto here, and this is then where I've wired this out. So this is quite a useful connector. So this one just connects like for like up here, but then I can wire this out, so if it's back to front or turned around I can just wire these out. So if I pull this off, so I could turn that around, put it in a different way around, and that's useful if I'm still working out exactly which way around to do the cables. So eventually I'll send that nice and neatly up there, and then basically wire that out in the top. What else have we got dangling around now? We've got this one here, which is I think that's a DI bus going into here, and this one must be the address bus going up to the upper card. So again, I need to route that neatly off of there, route it up through the top of the case, and then over to the right. So I'll do this another time. I haven't done them now because actually I've run out of cable. I have to ribbon cable, so I'll get some more, and then I can just crimp on some new connectors and make it all nice and tidy. But the good thing is there's less connectors hanging out the back now. Before it was a real mess, and now it's just a slight mess. So that's probably about it actually for that. So I guess what I'll probably do now is flip down to the front of the machine and probably show you it running a program again, just to prove that the address bus, the DC bus, and the control bus down here for the Y is all working as it should do. Actually the Y bus, yeah, that comes down here and goes off here as before. Luckily that was already the right sort of cable and the right way around. So yeah, looking a little bit neater. It's certainly worth noting that because this is the printed circuit board version, there's loads more room down here because you haven't got all these cables here, and it should be a lot more robust and a lot more reliable. There is a fault down on this Z bay down here, somewhere around there actually. If the register cards are pushing a bit too far, it makes a bad contact, and it'll just be all these. So I might end up replacing all three of these with a printed circuit board, or a homemade one as well if I do one. But we'll see how we get on. Right, anyway, run to the front. Okay, I'm just going to run a very simple program this time. You've probably seen the arithmetic sequence I've done in the past. I'll do the same thing, but just probably the first couple of lines from it. First of all, let's just check everything's working okay. So at the moment we've got the memory cards plugged in down here, which is all grand. So what I should be able to see is if I set a pattern on the address bus, say if I just set 3 on there and 1 at the back, if I load that as address, notice that when I pulled that on, you can see the pattern down there just coming on the address bus lights down there, so that's good. Now that's there. And if I load all bits on and load that as an address, if I then run the incrementer one step on, basically you'd see it move on to the next LED. So basically if I do, I remember how to use this, so if I select the program counter, load the incrementer. Have I done that right? Select program counter. I'll tell you what, I'll just clock it through instead. Let's get those things going, and then let's just clock that through. So there you go, you can see it's now onto the next address bus. And then that'll go up one more again, which is fine. Cool, so let's reset that. And just wipe out the address again. Cool, so that's looking good. What else can we do? We should be able to read the contents of the memory at the moment. So because when you switch this on, the memory will just have a random value in every location, just because that's how this sort of memory works. But as you can see, basically the value that's on the data bus there is matching the data bus up here. If I load a different location into memory, so let's say we'll load that point into memory, and then if I do a select the program counter, so that's the address bus, and then read the memory, we'll get a different value, but again it corresponds to the one down there. Okay, right, so that's enough of that. So that's all working as it should be. So I'll bring up on the right hand side of the screen the details of this instruction program I'm going to do. I've got a paper copy in my hand that we'll work through. So let's set the first instruction, deposit that, and next instruction, then one of those, then one of those, then one of those, and then final instruction is that. Cool. I'm going to finish off with all bits on, which should just confuse the computer into stopping. Cool, so what we can do is if we start back at the first location in memory, should be able to examine each part of this program and just make sure it's working okay. So if I look at that, yeah, that looks good. Next instruction, and all this is doing is just stepping through memory just so I can make sure everything's okay. Cool, so that looks all fine. Just load the memory again. So what I'll do now is I'll step through the program by hand cranking the clock. So what I can do is if I just step through the do the clock step here, I'll try and keep my hand out of the way of everything. So the first instruction we're looking for is to load the value of 2 into register B. So there we go, so you can see we've got a set A, B, and it's going to load the value of 2. So if I step through that, you see at the top right then it just loaded the register B, and the register B should now have the value of 2, which it does. So I can carry on clocking on to the next instruction. The next instruction should then be to load 4 into A. There's your 4. And if I clock that through, watch out for A being selected. There you go, and that's now put the value of 4 into register A. Right, so next one's going to be move A to C, or a copy A to C. So again, if I step through, you'll see the command come up there. Basically, this first bit is saying that it's going to move it to A. This bit's saying it's going to move it into C. So again, watch up here for the lights going through. So there you go, so that's selected A and it's loading C. And you can see down there then it's on the C down there, it's set the value. Next one's going to be an add, so ALU. There you go, gone to an add, so 2 plus 4 equals 6, which you get there, and it's going to put the value of that into register A, which you can see up there. And now A just contains that value. Okay, next instruction is going to be copy A into B, so I want to copy that value into there. So there you go, there's your move instruction, there's the transfer, and that's ready for the next instruction. And then the last one is the increment, so this will be a, there we go, there's the ALU instruction of an increment, which adds 1 to the value, giving us 7. And that goes into register A. And that's it. And then the last instruction there is just all on, which should basically just lock out the sequencer. So you can see there the sequencer just gets stuck because it doesn't know what instruction that represents. Cool. So if I reset the clock, reset the address bus, I can reset the sequencer so it's ready to go again, and then just run that whole sequence off quicker. And there you go, get stuck again, stop the clock, and it's all working as expected. Brilliant. Okay, so that's that backplane in place. So the next job now will be to start adding some more cards. So we need to add some more registers. So we need to add a memory register so that we can store and load values in the memory, and that will tell us the address that we want to store those values into. There are also what other cards have we got? Yeah, so the other one is the jump register, the J1, J2. So what that'll do is that'll allow us to jump to different parts of the program, and that's where it starts getting interesting then, because depending on the outcome of an ALU operation, we can jump to a different location in memory. That allows us then to do things like subroutines, or we can start with branching logic. So we can say if a value 0, go one place, and if it's not, go somewhere else. So that's where the computer starts getting really powerful. So they're going to go in there. Now, registers are quite boring to make. However, as a sneak preview, I've got one of these. And this is something I'll cover in one of my next blog posts, basically. So I've farmed this out because these are way too complicated to do on a wire wrap, and they're quite boring. So I thought, right, I'm finally going to just send it out to a fab. This is my own design, which I'll go through on my blog shortly. But yeah, that's basically the next thing. We'll have 3 of these, which will fit in this slot, and this slot. And basically that'll give us 3 registers. So it's the memory register, the jump register, and the return register, which is basically when you've done a jump to somewhere else in memory, that's where you can store the value of where you want to come back to when you're finished. And that will basically give us the branching logic on the computer. Right, I'm going to stop there and edit this video and get it up to YouTube.